Hello students, welcome back to Vidyalakshmi CBSE School YouTube channel, and this is Ajit Kumar, your chemistry teacher, who will be dealing you with class 10 chemistry topics. So for upcoming term 2, we have got two chapters from chemistry, namely we have got fourth chapter is carbon and its compounds, and fifth chapter we have got periodic classification of elements. So even in that fourth chapter, there are some deleted topics which we have to be concerned about it. But in the fifth chapter, we have all the topics to be covered for the term 2 portion. Okay. So in this video and in the upcoming videos, we will be dealing with the fourth chapter, carbon and its compounds. So this chapter has got many interesting topics in that, and it is all new to you. So if you follow the videos regularly, definitely you can get the concepts very well. So to start off this video, before that, let us see the contents of this chapter. First, we have got the introduction part, and then we have got what kind of bonding is formed between carbon or carbon based compounds. There is a special nature of carbon that we will be concentrating in this chapter. Later, we will be seeing the versatile nature of carbon. So, this properties which enables carbons to form millions of compounds. So, that what is the reason behind that we are going to study in this chapter as well. And then electron dot structures of carbon based compounds, and then we are going to see isomers. What is isomer, what are the types of isomers, and to be specific, we will be concentrating here on structural isomers, and at the last we will be focusing on functional groups and homologous series. And after the topics which is after homologous series, it has been deleted, so no need to worry for the term 2 part. So let us start with the introduction part. As we all know, carbon has somehow is been related to our life in our day-to-day life. Okay, in somehow it would be related, we would be coming across it. For example, even carbon is found in atmosphere inside the Earth's crust, and it is present in all living organisms. Okay, and then carbon is present in fuels like wood, coal, and then this charcoal, coke, petroleum products. Mainly petroleum products are nothing but namely petrol, diesel. It is all made up of hydrocarbons, which means that it will be consisting of hydrogen and carbon. Okay, and then natural gas. All these substances, there is a existence of carbon in it. Okay, and then carbon is present in compounds like carbonates and hydrogen carbonates. Carbonates you will be knowing CO3, and hydrogen carbonates compounds which is having HCO3. Namely, you would have studied in term 1 baking soda, right? Sodium hydrogen carbonate, NaHCO3. So it is all substances where we could find the presence of carbon. And then carbon is found in free state in the sense it is not mixed with any other substances or any other with impurities. It is existing in a free state like how gold, silver appears. The same way carbon is also appearing in free state in the form of diamond, graphite and fullerenes. These also will be concentrating in this chapter. We will be studying what is the difference between these three substances. Diamond, what kind of bonding is formed in there between carbon, and then in graphite and then in fullerenes. So to move on with the next slide, foods, clothes, medicines, books and many of the things which we use are also made up of carbon based compounds. Okay, and then the amount of carbon present in the Earth's crust and the atmosphere is quite meager. The point to be noted this is, in this Earth, the existence of carbon is very less. Namely, if you see in the Earth's crust, it has only 0.02% of existence in the form of minerals, and in the atmosphere it has got 0.03% in the form of carbon dioxide, which is in the form of gaseous. It is present in gaseous state. Though the percentage of existence in Earth's crust as well as in the atmosphere is very less, but it has got very wide applications, very wide uses to us. So that is what the point given. In spite of this small amount of carbon available in nature, the importance of carbon seems to be very immense. Immense in the sense it has very huge applications or uses to human existence. Okay, some of the images are also given. This shows the image of a diamond, and these are the substances like coal, graphite. It is all present here. Okay, so let us move to the next part. Bonding in carbon, the covalent bond. So in term 1, we would have studied about a kind of bond, namely ionic bond. We would have studied that it is formed between two oppositely charged ions or two oppositely charged particles, namely cation and anion. So what is this covalent bond? That is what we are going to learn now. Okay. So most of the carbon compounds are poor conductors of electricity in solution or in the molten state. It is poor conductors of electricity in both in the solution form as well as in the molten state. But we have seen ionic compounds are good conductors of electricity except in solid state. In molten state it is a good conductor of electricity, but in solid state ionic compounds will not conduct electricity, that we have studied in term 1. Now here carbon compounds have low melting points and boiling points as compared to ionic compounds. The reason is ionic compounds or the bonds which is present in ionic compounds, we call it as ionic bond. That ionic bond is very much stronger compared to this covalent bond. Okay. Then since they are non-conductors of electricity, it is known that bonding in this compound does not give rise to any ions. We know that only if there is a presence of ions it will conduct electricity, but if there is no formation of ions in their bond, then how come it is possible to conduct the electricity? That is why most of the carbon compounds are non-conductors of electricity. So we have come across these properties and all. Let us discuss in detail why carbon is able to form this covalent bond. What is the reason for that? Before that, let us see the atomic number of carbon. Atomic number of carbon is 6, and you know the electronic configuration K shell, it carries 2 electrons, and in L shell it carries 4 electrons, and a schematic diagram is given here. It has got nucleus, and we know that inside nucleus we have got protons as well as neutrons. Here how many protons will be present? 6 protons will be present inside the nucleus, and outside the nucleus 6 electrons will be present. In K shell there is 2 electrons, and in L shell it is got 4 electrons. So altogether 6 electrons are present. Okay. The reactivity of elements is explained as a tendency to attain a completely filled outer shells, that is to octet configuration. We know about valency. Okay, valency is nothing but the tendency of an atom to gain or lose electrons. So for what purpose it has to gain or lose electrons? Yes, the reason is to attain that octet configuration or completely filled shells configuration. So to attain that, few elements might lose their electrons, few elements might gain their electrons. For example, if you consider the elements forming ionic compounds achieve this either by gaining or losing electrons. Let us consider an example, sodium and chlorine. We know that atomic number of sodium is 11 and atomic number of chlorine is 17, right. So if you see the electronic configuration 2, 8, 1, and if you see for chlorine 2, 8, 7, right. So it has also got 3 shells KLM, and chlorine has also got 3 shells KL and M shell. And if you see the valence electron of sodium it is 1, and if you see the valence electron of chlorine it is 7. So we know to find valency of sodium, it is the valence electrons are below 4, so we will consider the same number as the valency. So valency of sodium is 1. And valency of chlorine, it has got 7 valence electrons which is above 4. So in that case what we will be doing? We will be subtracting it from 8. So 8 minus 7 will give us 1. So valency of chlorine is also 1. But the difference between these two elements is sodium is going to lose this 1 electron and attain octet state. Whereas in the case of chlorine, it is going to gain 1 electron and it is going to attain octet state. So by gaining and losing, it forms an ionic bond between them and it attains a octet state. But in the case of carbon, it has got 4 valence electrons. We know if it is below 4, it will lose. If it is above 4, it will gain. But what will it do if it is exactly having 4 electrons? That is what we are going to see. If it is having 4 valence electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration, or we can say it as octet configuration. We are going to check whether if carbon loses electron, what is going to happen, and if carbon gains electrons, what is going to happen, that we are going to see in the next slide. Okay, let us take the first chance. If carbon gains 4 electrons, already carbon is having 6 electrons in it, 2, comma 4. Okay. It could gain 4 electrons forming C4 minus anion. We know that if an atom gains electron, it will be formed as anion, right? And at the same time, if it loses electron, it will be called as cation. Now, in this case, if it is gaining 4 electrons, because it needs 4 to attain octet, if it gains 4 electrons, it will be difficult for the nucleus with 6 protons to hold on to 10 electrons. The reason is, already carbon is having 6 electrons in it as well as 6 protons. Protons are present inside the nucleus, electrons are present outside the nucleus. Now, the thing is, extra 4 electrons are coming into the carbon atom. So, altogether how many electrons will become? 6 plus 4 will become 10, but protons will be same, it will be a constant thing, there won't be any exchange of protons. Now, the thing is, the 6 protons which is inside the nucleus, it will be very difficult to hold on 10 electrons which is outside the nucleus. So, that will become an unstable state and it is not possible to exist. So, the chance is not possible. The next chance, what would happen if it loses 4 electrons? Again the same thing, carbon 2, 4. If it loses 4 electron, what is going to happen? The thing is, to remove 1 electron, for example, if you are going to remove 1 electron, we need some energy. Only if we give energy, electron can be taken from that. But here it is at 4 electrons. So, we will require more amount of energy. That is what they are saying. It would require a large amount of energy to remove 4 electrons, leaving behind, how many electrons will be there? With 6 protons holding on to just 2 electrons. So, out of 6, if 4 electrons are removed, remaining how many electrons will be there? Only 2 electrons will be there. That state is also not possible because we need more amount of energy to remove those 4 electrons from the carbon atom. So, this is also not possible. Gaining electron is not possible. Losing electron is also not possible. So, what is carbon going to do to attain octet configuration? That is what we are going to see. So, to overcome this problem, carbon shares its electron. This is the important point to be noted. Carbon, instead of gaining and instead of losing, it shares its valence electron with other atoms of carbon or with the atoms of other elements, to whatever the elements it is getting bonded. So, kindly note down this point. Carbon is not going to gain electron to attain octet. At the same time, it is not going to lose electron to attain octet, but it is going to share its electron with other carbon atom or with other elements to form a compound with attaining the octet configuration. Carbon shares 4 electrons with other atoms to attain stability, resulting in the formation of covalent bonds. Now, the thing we have to concentrate is covalent bond. How covalent bond is related to this topic here? We know ionic bond is formed between cation and then anion, and there takes place transfer of electron. Ionic bond represents transfer of electron. An electron gets transferred from metal to a non-metal, which results in the formation of ionic bond. But whereas in the case of covalent bond, it forms only if an atom shares its electron. So, obviously, carbon shares its electron and it is going to form what kind of bond? Yes, it is going to form covalent bond. So, before seeing the covalent bond formation in carbon, let us look into the smaller molecules, how the covalent bond is being formed, and then in the next video we will see the covalent bond formation in the carbon based compounds. Okay. So, formation of covalent bonds. Covalent bond is a chemical bond formed by the sharing of electrons between atoms, or we could say in another way, it is nothing but mutual sharing of electrons. Mutual sharing of electrons. If you consider an atom A and another atom B, both are going to share its electron to form a covalent bond. If A gives, or if A shares 1 electron with B, at the same time B will also share 1 electron with A. I hope you understand. If A atom gives shares 1 electron with B atom will also share 1 electron with A. The same time, if A shares 2 electrons with B, B will also share how many electrons? 2 electrons with A. This is what we call it as mutual sharing of electrons, which results in the formation of what kind of bond? Covalent bond. Now I hope you could understand the difference between ionic bond and covalent bond. There, transfer of electron takes place in ionic bond, whereas in covalent bond, sharing of electrons takes place. Okay, fine. The sharing of one pair of electron results in the formation of single covalent bond. Like as I already said, if A shares 1 electron with B, B will also share 1 electron with A, which results in the formation of single covalent bond. If A shares 2 electron and B also shares 2 electron, it will result in the formation of 2 covalent bonds. Right. If A shares 3 electron with B, how many bonds will be formed between them? Yes, it will form 3 covalent bonds between them. And we know that each bond will consist of one pair of electron, right? So this is about that. A, if shares 1 electron with B, it will form single covalent bond. If it mutually shares 2 electron, each atom, it will form 2 covalent bonds. And A and B, if it shares 3 electrons each, it will result in the formation of 3 covalent bonds between them. Okay. So now let us see some examples on formation of covalent bond. So the first thing that we are going to see is hydrogen molecule. How the covalent bond is formed in hydrogen molecule H2. Hydrogen molecule H2. So we have got 2 hydrogen atoms. Yes. So each hydrogen is having how many valence electron? Yes. Before that, let us see the atomic number. Atomic number of hydrogen is 1, and it has got 1 electron in the K shell, which is the first shell as well as the last shell for hydrogen. So to see the formation of hydrogen molecule, let us see the electron structure. Hydrogen has got 1 valence electron, the first hydrogen. At the same time, second hydrogen is also having 1 valence electron. Now, this first hydrogen, to attain a stable state, it needs 1 electron. It needs 1 electron from another atom. At the same time, this hydrogen, second hydrogen also, it is already having 1 valence electron. It also requires 1 electron to attain a stable state. So, both the hydrogen atoms mutually, it is going to share its valence electrons to each other. This hydrogen is going to share this valence electron with the second hydrogen. At the same time, this second hydrogen is going to share this valence electron with the first hydrogen. So, there forms a covalent bond since it is a mutual sharing of electrons. So, now to see whether it has attained octet state or not, we are going to draw circles for it. So, you could see in this circle, hydrogen has got 2 electrons, which means that it has attained a stable state. If let us see for the second hydrogen, yes, so both the hydrogen atoms has now attained a stable state, and this bond formed is what we call it as covalent bond. So again, to recall, covalent bond is nothing but mutual sharing of electrons. Please do remember this statement, mutual sharing of electrons between 2 atoms. So this is the example for formation of covalent bond in hydrogen molecule. Let us have some practice on few more molecules in this video. Okay. So next we are going to see is oxygen molecule. So we know oxygen gas, and the atomic number of oxygen is 8. So there are 2 oxygen atoms. Let us see the oxygen atomic number is 8. K shell, it has got 2 electrons, and in L shell it has got 6 electrons. So altogether 8 electrons are there. And how many valence electrons are present in oxygen? Yes, it has got 6 valence electrons in it. So to see the formation of oxygen molecule, we will be representing the electrons of oxygen, valence electrons of oxygen here. and at the same time this oxygen is also got 6 valence electrons. So now the first oxygen, it has got 6 electrons in the valence shell. So to attain octet state, what it is going to do is it needs 2 electron. If it gains 2 electron, it will become octet, right? At the same time, that second oxygen also, if it gains 2 electron, that will also become octet. So both the oxygen atoms needs 2 electrons. So what it is going to do is, this oxygen atom is going to share these 2 electrons with the second oxygen. At the same time, the second oxygen atom which is present here is going to share the another 2 valence electrons with the first oxygen atom. So let us see the formation now. Let me write it again. You might be thinking why we have to represent only the valence electrons. The thing is, if an atom is going to react with another atom, only the electrons present in the valence shell is going to be involved with the reaction. Either it is gaining or losing or sharing. Okay, so keep this point in mind. So these 2 electrons are getting shared, as well as these 2 electrons are also getting shared. So now we could see there are 2 covalent bonds formed between oxygen atoms in the oxygen molecule. Now to check whether it has attained octet state or not, let us draw the circles. You see here, inside the circle, it has got 6 electrons, and these 2 electrons are shared with this. So 8 electrons has been attained. At the same time, for second oxygen atom, you could see already 6 valence electrons are there. In addition to that, 2 electrons are also being shared. So altogether 8 electrons have been obtained. Clear? So we have seen the formation of hydrogen molecule as well as the oxygen molecule. Let us see a few more examples. Next we are going to see about the covalent bond formation in nitrogen molecule N2. We know the atomic number of nitrogen is 7, K shell 2 and L shell it is 5. Okay, so 5 valence electrons are there, its valency is going to be 3, right? So whether it is going to gain or lose, yes, it is going to gain 3 electrons to attain octet state. But in nitrogen molecule, we are going to see what is happening. Okay, so 5 valence electrons are there. Right. Now the first nitrogen, it needs 3 electrons, right? At the same time, second nitrogen also needs 3 electrons. So what is going to happen? By now I think you will have judged what is going to happen. Yes, both the atoms are going to share 3 electrons each. This is going to share 3 electrons with the second nitrogen. Second nitrogen is going to share 3 electrons with the first nitrogen. So what is going to form? A covalent bond is going to be formed between them. So how many covalent bonds are formed? Yes, 3 covalent bonds are formed between nitrogen atoms in the nitrogen molecule. So to check whether it has attained octet or not, what we are going to do, we are going to draw a circle. Already 5 valence electron and 3 electrons are shared here. So 5 plus 3, 8. At the same time, for this nitrogen, already 5 plus 3, it is 8 now. So both the atoms, by mutually sharing electrons, they form a covalent bond and also they attain the stable state. So this is about the covalent bond formation in molecules which is apart from carbon. We have just started off with lighter molecules. In the next video, we will discuss about the covalent bond formation in carbon, what are the other properties of carbon which enables it to form millions of compounds. So other all things we are going to see in the next video. So I hope this video was helpful to you. Thank you, students.